Hey, welcome to my TromboSpace channel. I'm Trombonaut, and TromboSpace is where I make games. I've been teaching myself C#, C++, Unreal, and Unity game engines for about 2.5 years now, and I've had this dev blog for almost exactly 1 year, 1 year and a month right now. So if you are a beginner or intermediate game developer, or if you just like thinking about gaming and how games are made, stick around because maybe this blog is for you. This is actually my first audio log, and if you want, you can follow along on my website where I also have my usual blog and images. Apart from that, though, feel free to like and subscribe on this video, and let's get into February's blog. So today we're going to talk about what I did last month. So we're going to talk about my multiplayer networking progress. To lead us into that, I'm going to talk to you a little bit more about my generic action game development library that I'm making. This is a bunch of generic scripts, kind of an overall framework for making games that I'm creating. I'm going to talk about my networking approach from there. So sort of the big picture now, looking back at it, how did I do the networking that's in there now? Because, spoilers, the progress is complete. So forget that first item. That's the progress. Progress complete. I've got multiplayer stuff happening. After we talk about all that, the generic development framework, the networking approach, then I'll tell you about what's coming next for TromboSpace, my whole game dev project here. If you are here to talk about a specific game and concrete stuff about that game, I don't have anything for you today. This is still kind of just more theoretical. But if you like thinking about how these things are put together and all the different ways you can do it, and maybe you're trying to put together a game yourself, I hope you get some ideas from this today. So back to item number 1, multiplayer progress. Multiplayer has progressed. I started this in January. This is now March. So my goal was to finish networking by the end of February. And I technically cheated. It was March 1st when I finished my networking integration, but I did it. It's done. It's in. I have networking capabilities on my generic kind of action game co-op library now. So what does that actually mean? I've got peer-to-peer networking via relay servers. So you might know what that means. Basically, you open the game, you have a button, host, you can start the game, start up a server, and other people can connect to you. Now, depending on how that's done, people can connect directly to your machine. If you do port forwarding, a little bit of complexity there, not too crazy, but of course there's easier ways to do it. I've done instead a relay server setup with kind of the Unity relay services. So a little bit of cost overhead if I ever have a big game, but right now it's free. It's also kind of new from Unity, but their API, not too difficult to use. I had a little course that you'll find on my website that I had to kind of help me through the basics. I've used Mirror before, I've used Photon before, I've used Fishnet before. These are other multiplayer frameworks, but this one was really easy and it connects to a bunch of other cool things that Unity offers. So anyway, basically what this means is you can start the game, you can host, that gets the game running on your machine, and then by opening that server, you have also connected to Unity's relay service, which means there's another computer out there that's actually acting as sort of like the front door into your machine. So instead of players connecting directly to your machine, you send them an invite code where you list yourself on, as a public lobby. And when someone connects to you, they don't need your IP address and everything to connect direct to you. They just need to connect to that relay server, which will be done automatically, which then connects them to you. So that's it, really. Join codes, public lobbies, private lobbies, it's all in there. And my favorite part is, the way it's set up, there's no requirements for account creation. So I don't know about you, but when you log into a multiplayer game and it's like you have to first log into one or more third-party portals, sign in there, and that lets you connect to their networking service. I don't like that. So there's no account necessary. Despite this, I do have some internal stuff within the game that offers basic hosting kind of security and banning capabilities. So you don't have this third-party profile that can be banned, but there is sort of an in-game little identifier on connection that people can boot you if you're being a butt, basically. Okay, so how does that work? Sorry, that's a big spiel. Audio log stuff. I hope this is okay. But how does it work? So it's all pretty theoretical what I'm about to say, and you're either going to love this or you won't. Today, like I said, it's either pretty dry, abstract discussion, or nothing. Sorry, it's all dry, abstract discussion. So I hope this is good for you. First, let's step back a minute into the big picture. So I'm building a generic action game development library, and to help us understand the networking side of things, how that works, I'll boil down my basic library for you into kind of two overly simplified parts. Those two parts are entities and systems. I've created entities and I've created systems. So a system would be something like animation or audio or movement or similarly kind of like very general functionality, capabilities of the game. Those generally don't need to be networked exactly. So let's talk about entities. So an entity is something that interacts with those systems. This is like a character, an environment, an obstacle or something. And obviously these things, many of these things need to be networked. So let's focus on that today. I'm going to tell you more about my entities framework. I haven't talked about this much before on the blog, but it's, we're going on the theoretical dive, so let's just do it today. So you can think of my entities framework as a collection of general skeleton templates. So right now I have 7 templates in total. They are the session root entity, the presence entity, we've got the scene root, the actor, the prop, decor, and FX. So each of these templates is kind of self-descriptive. You can imagine, for example, what is an actor in a game, what is a prop, but let's not focus on that today. All of these things, they have slightly different requirements and responsibilities. That's why I have 7 categories. But for the purposes of networking today, let's just focus on their similarities. So for each of these generic entity templates, basically they let me quickly add on different modular systems in just about any combination that I want. So this allows me to rapidly create game-specific entities. I'll give you a concrete example in a second, but in general, this is called component-oriented programming. Maybe you've heard of that before. And for code nerds among you especially, you can probably think of COP, component-oriented programming, as kind of a cousin of OOP, or object-oriented programming. So COP and OOP. So I'll explain my entities here with an example of COP, that's the component setup, to show you how my framework works and how it lets me do some very cool, very efficient things with my networking. And when I say efficient, I mean, yeah, it's going to perform well, but also, more importantly to me, it's going to let me quickly develop new games by reusing code. So if you're thinking about making games with code, definitely pay attention here. Okay, so let's pretend now we're making a game and we want to put a cat into our game, and we want to synchronize our cat on a network. So we're going to talk about component-oriented programming, what that looks like. We're going to talk about object-oriented programming, how that will look. In OOP, that's object one, we would look at the cat as one object. Okay, that's where the name comes from. So consider that object's behaviors. If it's a cat, it should move, it should meow, maybe it should scratch on some stuff, maybe it can look and listen. And if it has that kind of awareness, maybe it can react to changes in its environment as well. So a lot of complexity there. And in OOP, all of this behavior would go onto the object basically as one massive script. The script is the object, and this script will tell us everything that makes this cat a cat, or whatever object you're making. So you'd probably use some sort of inheritance pattern to make your life a little easier. You might say that the cat is an animal. So now we have kind of two scripts. We'll say an animal is anything that can listen, look, eat, and move, and these things. And so now technically your cat is only going to say, or it only needs to say, what a cat can do that is in addition to what all the animals can do. So what that does is for all of your animals, you can reuse that animal code. And then for the cats, you just have this extra cat code. And then, of course, this is inheritance we're talking about. So basically, the cat is an animal. So on that one script, you have all the functionality in there still. So it's still a cat object. And then when you want to network your cat object, you would go into your cat script and your animal script, if you're doing it that way, and you would write code in both places to hook your cat into your networking systems. So that's all well and good, but what if your game is about a zoo, and maybe you've got dozens, or let's say hundreds of different animals? So now you need to write behaviors for all of those animals, and you need to make sure that you write your networking code for all of that as well. And if that sounds like a big job, that's because it is. This is a lot of work, and that means a lot of opportunity for human error in your coding. And that means a lot of debugging, which means a lot of just labor hours getting the job done. So this means good luck finishing your zoo, and who knows if you'll even have time to finish the rest of your game at this rate. So let's switch over to component-oriented programming, where things are a little different. So this is the system that I'm using. You don't have a cat per se. I don't have a cat. You don't have this master script with dozens of different behaviors and data containers that define the cat and its current state and all of its behavior. Instead, each of these behaviors is broken out into its own script, and these different scripts are called components. And that's where this name is coming from, component-oriented programming. And if you're a little loopy, you want to take a little extra like me, you can make all of these data containers their own components as well. So basically, I have 2 kinds of components. I have effectors, which are my logic scripts, and then the other ones I call blackboards, which are data scripts. Together, the effectors and the blackboards come together to make a system module. So it might sound like I'm making more work for myself, but hang on. So my movement system module has one movement blackboard, and all of the movement data gets written to or read from that blackboard. There's only one. And then I get to have a number of optional effectors, as many or as few as I like, actually. I can have maybe an input effector so that the player can do movement. I can have an AI navigation effector. Maybe I want to put a collision rebound effector on there to get some kind of cool bouncy physics movement. Just about any kind of movement related behavior I might need can just go on this module as an effector. Then my movement system module and any other system modules I want for my cat, they can all just be dragged onto an empty object that I will just arbitrarily call a cat. For example, one of these modules might be like a rendering module or an animation module, and that's maybe where it looks like a cat. Not because I wrote code to make it look like a cat, but because I gave the rendering system a cat mesh. And so it knows, okay, this is a cat mesh. I'm supposed to animate it. Maybe I'll give it a set of animations called like, walk, run, make noise. And on a cat, this animation set might be like cat animation movement, a cat noise when it makes a noise and does the body movements, the animation for a noise. But all the code is the same. So if I wanted to be a dog, for example, the dog module just needs, a dog mesh, a dog set of animations, but all the animations have the same names as they do for cats. So it just says move, eat, growl, or make noise. Maybe it'll bark. Anyways, so very generic. The code is reused, and some of the specific kind of assets called by that code, those get changed, but the code doesn't. So now that we're looking at it this way, we see a cat or, any of these kind of objects that we were calling them, they're just an assembly of particular behavior modules. So we take an empty object, we plug on a movement module, a noise module, an eating module, a look module, an animation module. All of these things are just modules. So now if you want to add hundreds or even thousands of animals to your game, component-oriented programming doesn't make this difficult. It's quite simple. Just drag and drop your desired modules onto some empty object until that object can do what you want the new animal to do. So in that process, you're not writing any new code unless you need a new system or behavior. But the flip side is, once you do write any new system or behavior, it is now just another module that you can also apply to any other appropriate animal. So it's entirely self-contained and reusable. So, okay. Long story short on that, before we get into networking, this kind of component-oriented programming is just going to let me focus less on code and more on game design. But the other part of my game design plans, of course, that I need the code to do is multiplayer. So let's talk about how all this connects now into networking and multiplayer. So with this component-oriented programming, I don't need to write a network cat, right? I don't have a big cat script, so I don't need to go and write a bunch of network code into it. Instead, I just need to find like a network module and pop that onto the cat, because that's what all this is, right? It's just kind of plug on, plug off, that kind of thing. But in reality, of course, it's slightly more complicated than that because there is no cat. So I can't just put a network module on the cat. Instead, I have these modules that I just need to put an add-on for every module. So sort of just another effector, really, right? They have one blackboard, many effectors. So I need some sort of network effector for the modules that I want to network. So do I need to synchronize animation? Then I can just write a quick synchronization add-on or a NetSync network synchronization effector for the animation module. Or another example, maybe all of my animals have a health module. I should probably synchronize that so everyone's kind of living and dying at the same time. But it's as easy as writing one script, one effector, a health network synchronization effector. So I call each of these little add-ons a NetSync, and I find them incredibly powerful. Basically, they all follow the same pattern, and here's why I love them. So if I write one NetSync for my health system, remember my health system is reused by all of my things that have health. So by writing that NetSync, I have now just synchronized every health system for every animal in my game. So not only that, but this script is incredibly simple, right? It basically just has one job: do the networking. So it just watches the server and it watches the clients, and all it's looking for, in this case of the health system, it's just looking for changes to health data. So it's reading that one health blackboard that my module has. And then it just announces those changes to the network for the other NetSyncs to copy. Because remember, this script basically has an instance running on the server and all of the clients. They all have these NetSyncs, and basically all of the NetSyncs can talk to each other and make sure that the game is showing all the same stuff. So there's only one NetSync script for each different system, but it does function differently whether you're on the client or the server. So that script just does a check to say, hey, are we in charge of this game or not, right? And if they're not in charge of the game, then they can't just publicly broadcast their changes. Any client who's not the host, basically, they have to push their changes first to the host, to the server. And this is great. This is actually going to make data security and just overall prevention of cheating very easy. So, concrete example. Let's say you pick up a health thing. Now let's go back to your cat. So your cat maybe eats a fish. Now it gains some health, okay? Oh, like Stray. Yeah, pretend you're playing multiplayer Stray. And let's say you have health, you eat a fish. I know there's not health in Stray, but stay with me. So you, the client, you're not the boss. But this system, because the NetSync is, it's watching the health system, but it's not the health system. So the health system on your machine, when you eat that fish, it's going to let you just update your health, no problem. But then your NetSync is going to tell the server, hey, this player over here just updated their health. So the server, if it wanted to, could just automatically publish that data to all the clients and complete the synchronization. But for anything that I suspect might be susceptible to cheating, so if someone if I think there might be a mod for maybe infinite health every time someone, presses, I don't know, H or something, a mod or a cheat where they can kind of do stuff they shouldn't. This is where the server and the NetSync system works out really well. The server, instead of just automatically publishing the new information, can look at the health change, and then I can just add one line of code in there to say, hey, before you publish that information, check it. Is it legal? So it can look at the health change, it decides if the change is legal or not, and if it finds that the change is illegal for some reason, then it just doesn't publish the change, which means that no other clients ever learn of the change, so this cheating is quite inconsequential. And not only that, but the server can then say, hey, you weren't supposed to do that, and it can forcibly push and revert their data, like push back, and say that change is not allowed, and it'll revert their data. And if there's some sort of penalty for that, it can apply that as well. So all this behavior is handled by one NetSync script, mind you. And it sounds like it's doing a lot, but really it's 4 jobs, and they're almost literally just 4 different functions in the script. It just has to read data from a blackboard. It has to communicate that data to the server. The server then validates that data. And of course, the server is still using its own version of the NetSync. So this is still just one script. And then it can choose to publish or revert that data. So it's one script, it's 4 jobs. I love it. I write one of these for any system I make, and suddenly that system is networked. It's working really well. So then what's next for TromboSpace? My networking is in place, and so it's time for me to start up my first multiplayer game. I've built this entire system for my procedurally generated co-op horror survival game called One Wicked Night, but I'm going to keep that project still on pause because first I want to make smaller scale multiplayer games to really put my library through its paces. One thing I will say, there's a lot, this is already a long blog, but there's a lot going on with the networking stuff. I did talk about 7 different entity types, and each of those entity types has different roles and responsibilities in a game, which means each of them have slightly different requirements for their networking, which I'll get into probably in my next blog. But I just want to let you know, One Wicked Night is still on hold. I am coming out with a new game. I'll be chronicling its development in these blogs. The prep work for that game is already complete. So the game design document, initial Unity project file is done. Obviously, I just take my generic TromboScripts library that I made and I just dump it into the new project. So a lot of my systems are basically up and ready to go. But I won't be talking about the specifics of that game yet until I have some finished stuff to show you. Again, my audio blogs, I don't want to spend too much time on them. I was doing video blogs for a while, but the editing time is just, I'd rather put it into games. So if you're still here, if you're still listening, that's great. I'll do this again. If you got some feedback for me, please drop it in the comments. I'd love to read it. I do want to keep these pretty low stake, but the text blogs just feel very, cold. sterile to me. Videos, I think, are much more personable. So I think it's a happy compromise in terms of how much work they take and, you know, how much game development time they eat up. I think this audio blog thing together with the text website is where I want to sit for a while. So yeah, let me know what you think of that. Thanks for reading. Subscribe to my email mailing list if you want for big announcements. You can get that on my website, or you can join the TromboSpace Discord if you want to hear more about like little stuff throughout the month as well. Otherwise, I hope to catch you back here in April for my next dev blog. I hope you learn many interesting things that bring you joy before then, and I hope to see you here next time. Take care.